Welcome. Today I will walk you through our project. Endocare, it's an AI-powered tool that empowers women's health by detecting endometriosis symptoms early and supporting ongoing tracking. Endometriosis affects 1 in 10 women globally. That's over 190 million women. The sad reality is that diagnosis takes 6 to 10 years on average. During this time, women suffer from chronic pain, emotional stress, and reduced quality of life. Delay in diagnosis causes worsening symptoms, and misdiagnosis is extremely common. Early diagnosis is critical. It helps reduce the severity of symptoms, improve treatment outcomes, and increase chance of preserving fertility. Unfortunately, diagnosis is delayed due to overlapping symptoms with other conditions and lack of awareness, leading to misdiagnosis and ineffective treatments. Let's start with the execution of the project. So we need to first run the front end, and then there are two backend folders which are used for ML prediction model and RAG-based system respectively. This is the login page of the website where I have used Supabase as a database which is used for storing the data as well as for authentication of the user. This is the basic UI of the website. I have tried to keep it simple so that the user can easily find a required element. So as we scroll down, this is the calendar UI where user needs to enter the data on daily basis for 20 days. So let's see what exactly data is required. So this is simple buttons where user can click and enter the symptoms or how she feels during her period cycle. So this is the list of symptoms which can occur and which are necessary for the diagnosis of endometriosis. Once we select the symptoms, we can simply click on save entry. Then this data is stored in the database in real time. And when we click on the blue database icon, it has some options about the database like add multiple data or custom data and clear the stored data so she can start a new cycle for new month. When we go on monthly analysis side, this is the main part where all the analysis of the disease takes place, and it shows the number of days track, monthly progress, and analysis status. So let's see which APIs are getting called and how exact the data flow takes place. So when we click on analyze June 2025, the predict API is getting called, which is responsible for sending the payload of daily data to the ML model. Then the ML models give the response about the probability of the occurrence of endometriosis. Also, I have implemented a RAG system which has personalized AI agent which answers the question and does the diagnosis for the disease so that the user can take next step in the diagnosis process. Here you can see a personalized diagnosis of the disease which is done by an AI. I am using Deep6 API to get the input based on the percentage of the risk of the disease, and here you can see which are the important step reminder and also which next steps are recommended by the user, and also the priority of the steps is set so that user can see a simplified view for the next step. Also the user can ask personalized questions like what are treatment options, how accurate is this analysis, and so on, and this AI agent will answer the question efficiently. Also, I have implemented a visualization of the data. There are total 5 bars which shows the percentage of the symptoms and which are the most frequent symptoms. This helps doctor to analyze the disease more accurately and helps in the diagnosis process to make it even faster. This is the model's training code, which handles training and XGBoost classification model to predict endometriosis based on symptom data. It uses Smooth to balance the dataset by oversampling the minority classes and then splits the data into training and testing sets using train test split. A grid search CV is performed over several hyperparameters to find the best model, and the optimal model is then stored using JobLib, and its performance is evaluated with accuracy and classification metrics on the test set. And in the second code, this is the main model in inference. This part loads the trained XGBoost model and allows user interaction by taking binary input for various symptoms. It processes the input in the same structure as the training data, predicts the class label using the model, and shows the confidence or probability of the prediction. This code is designed for making a real-time predictions based on the user-provided symptom data. And for the RAG system, we have defined a FastAPI application that powers an AI explanation and QA service for endometriosis. It includes course middleware for front-end access and initializes an AI explanation service which handles generating personalized experience explanations and answering user questions based on the ML predictions. It has endpoints for health check, explanation generation, and specific question answering. If the RAG services fail or isn't initialized, the system provides a fallback explanation and recommendation based on the risk level for the prediction result. And this is the main schema of the database, in which the user's data is stored in the real time, and the authentication or authorization of user takes place. I have used Railway to host the two backend APIs so that it can be accessed in the front end. And here you can see the both APIs are deployed over here. And for deploying the front end part, I have used Netlify. Thank you. Endocare creates impact at multiple levels for user, early detection, better symptoms control, and easy access to guidance. What makes Endocare unique? Unlike general health apps, it uses AI specifically tailored to endometriosis. It focuses on early detection or early risk detection with personalized alerts. Endocare is designed to grow. Technically, it's hosted on scalable cloud platform and uses powerful AI tools. Operationally, it works globally and integrates with doctor and labs. Time being, we intend it to keep free for all users. Looking ahead, our vision is global. We aim to reach unreserved regions, integrate variables for real-time health tracking, and continue improving our health with larger datasets for more accurate early detection. Thank you for your time. If you are interested in collaborating or learning more, connect with me on LinkedIn.